Hi everyone. So I realized that I usually start off with a conceptual definition of the concept being explained in the lesson today. However, I think implicit differentiation is maybe best explained with examples, so I will go ahead to those. Say you're given the equation x squared plus y squared is equal to 4. Well, I want you to find the derivative of x squared plus y squared is equal to 4. So you would think, well, maybe the first thing you would think of is the usual way, which is explicit differentiation. So you would move x squared to the other side, solve for y by finding the square root of both sides, and you would try to find the derivative of the square root of 4 minus x squared. However, after a couple seconds, you would find this endeavor to be somewhat annoying, if not incredibly strenuous. It's not actually that difficult. In fact, I encourage you to try to find it that way, just to see if it matches up with our answer at the end. But implicit differentiation says that instead of doing that, you can just find the derivative of both sides, and then just solve for dy dx. So, in this case, I would find the derivative of every term. So the derivative of x squared is just 2x. But I want you to notice that the derivative of y squared is 2y times dy dx. And the derivative of 4 is just 0, because 4 is a constant. So now I'm left with 2x plus 2y times dy dx equal to 0. So what I originally wanted was the derivative, which is just dy dx. So I will try to solve for that using the usual algebraic methods. So moving 2x to the other side, I find 2y dy dx is equal to negative 2x. Dividing both sides by 2y, I find dy dx is equal to negative x divided by y. So that was actually incredibly simple. So let's move on to a slightly more complex example. So I'm given 3y squared x cubed is equal to 10. Again, using implicit differentiation, I find the derivative of 3y squared x cubed and the derivative of 10. Well, 3y squared times x cubed involves a product of variables, so what I need to use here is a product rule. So derivative of 3y squared times x cubed, which you can hopefully find out by this time, is just the derivative of y squared times 3x cubed plus the derivative of 3x cubed times 3y squared. So derivative of y squared is just 2y dy dx. I multiply that by 3x cubed, which is 6y x cubed times dy dx. Derivative of x cubed is just 3x squared. Multiply that by 3y squared, and you get 9y squared x squared. And derivative of 10 is just 0. So solving for dy dx again, I move 9y squared x squared to the other side, and then I divide both sides by 6y x cubed. So I find the derivative of this equation to be negative 3y divided by 2x. So what you have to remember from this lesson is that you're trying to solve for dy dx. If you realize this, everything else should come incredibly natural to you, especially after several years of math. So what you also have to remember is that you're trying to use that if your equation involves a product of two variables, then you have to use a product rule. And if you're finding the quotient of two variables, then you also have to use a quotient rule when you find the derivative of that term. Also, you have to remember that when you're taking the derivative of y, you solve it normally, quote unquote, and then multiply your derivative by dy dx. So say I want to find the derivative of 3y squared. Well, the derivative of 3y squared is just, well, I would typically say it's just 6y. So that would be my quote-unquote normal answer. So, but since I'm using y instead of x, I have to multiply this by dy dx. So the derivative of 3y squared is in fact 6y times dy dx. So thank you guys, hope calculus is a blast.